Okay, here is some more kinetics. It says here that a certain reaction is second order in N2 and first order in H2. Okay, and it says use this information to complete the table below. Okay, so we know that this rate here, this initial rate, is going to equal some constant here times the concentration of nitrogen, and that we're told is second order, so that's raised to the second power. Okay, also times the concentration of H2, okay, which is then raised to that first power. Alright, so use this information to answer these questions below here. So let's look at this first one. Okay, so it says here that nitrogen is held constant right here. Okay, whereas hydrogen then is increased to 0.173 molar right there. Okay, so what we can do then is we can take the concentration of H2, since nitrogen doesn't change. So we can take the concentration of H2, which is 0.173 molar, and looking at this change to get the magnitude of the change, then we can divide that by 0.120. Okay, and this is going then to give us, let's go ahead and pull up a calculator and do that. So we have 0.173 divided by 0.120, and then that change is going to be 1.442. Okay, so let's come here. That's going to then be 1.442. Okay, that is the amount that has been changed here in hydrogen. And since hydrogen is first order, I can then raise that then to the first power, which is going to be 1.442. So what I can do then is I can take that initial rate right here, 91.0 molarity per second. I can then multiply that by the magnitude of this change, which is 1.442. And then that should give me my answer for that first box right there. So let's go ahead and do that here. So that's going to be 91 times 1.442. And that's going to equal 131.222. So we come back here, that's going to equal 131.222. Of course, we're going to have to worry about and get the right number of sig figs here. So I can look over here and see that everything is going to be 3 sig figs. And so that is going to equal 131 molarity per second. That is how that initial rate of reaction is going to change as we change the concentration of hydrogen. Now in this last box that we have right here, then we're going to see that both change, and not only do both change, but that nitrogen here is of the second order here when we wrote our rate law. Okay? So we're going to have to account for both of these. Alright, so let's go ahead and take the magnitude of the change here. So that's going to be 0.0808. Okay, so that concentration goes way down. Okay, divided by 0.387. And because that is second order, we are going to then square that. Okay, and that is going to take care of the nitrogen, but we're also changing in the hydrogen, and so I'm going to take the change here, 0.575, and divide that by 0.120. That is going to be raised then to the first power. Okay, and that's going to be for H2. And so those are going to be equal. So let's go ahead and pull up our calculator here. Okay, and we're going to do 0.0808 divided by 0.387. Okay, and that gives us then 0.208. Okay, but we're going to 0.20878, so we're going to then want to square that. So that's going to be times, we'll just give it 0.2087855. That's enough digits right there. Okay, so the magnitude of that change then is going to be, bring that out because I forgot it already, 0.043591. 0.043591. Okay, so that's for the nitrogen. Now let's go and look at that hydrogen. That's going to be 0.575 divided by 0.120. It's going to equal 4.792. Okay, it's going to be 4.792 is the magnitude of the change raised to the first power, which is just going to be itself. Okay, so let's see how that's going to change here. So I'm going to take that initial rate, which is 91.0, and how's that going to change? Well, it's going to change by 0.043591 to that proportion, but it's also going to change to 4.792. Alright, so let's just quickly do that math. Alright, so that's going to be then 91 times 0.04351 times 4.792. Alright, so that new rate is going to then be 19, right at 19. So to 3 sig figs, that is going to be 19.0. Okay, so that's going to be the last one of that table. So it's 131 and 19. So we go back to Alex. First one is going to be 131 molarity per second, and this is going to be 19.0. It's 3 sig figs, so we have to include that. So when we click on check, as long as we did our math right, that should give it to us. And so we should be in good shape there. So again, these are doable, just have to be real careful. Watch out again if you need to, but you should use that to get the right answers here in Alex.